All right, so last week we looked at area of parallelograms and triangles. Today we're going to take a look at the rest of the area things aside from circles. So some quadrilaterals today, different types. So trapezoids, rhombi, and kites. The only new vocab you'll see is the height of a trapezoid, just because we haven't really delved into trapezoids too much yet. So the first thing we're going to look at is the area of a trapezoid. So here you can see the image, the two bases, so the top and the bottom of a trapezoid are the two sides that are parallel to each other, not the two sides that are diagonal and would intersect if they continued. And then they have the height there in the pink dotted line. So those are the parts to it. The formula, 1/2 times the height times the sum of the bases. So our first problem gives us everything we need, so we just need to use our formula. So our area of a trapezoid, I use T for trapezoid, the triangle symbol for triangle. Again, is I like to use the height times the sum of the bases over 2, similar to how I do triangles, base times height over 2. It's up to you, whichever one works for you. I know a lot of people don't like to use fractions in things, so this just makes the whole thing a fraction and basically makes it a division problem at the end instead of having multiplied by a fraction. So our height here is 1. Our base 1, it doesn't really matter which base is which. You can say it's the 3 as long as the other one is the 2.5. So our area of our trapezoid is going to be 1 times 3 plus 2.5 divided by 2. So the 1 doesn't really do anything. So we need to add inside of our parentheses. 3 plus 2.5 is going to be 5.5. And now we just need to divide by 2. And 5.5 divided by 2 gets us our area of our trapezoid. Our unit is centimeters. And it is going to be 2.75 square centimeters. Or centimeters squared. So that's all we need to find. The area of steel used to make the side of the razor blade there. Very tiny. So our next one is a deck that this guy's designing. So we have a few things we have to deal with here. We're missing one of our bases. We have the height because that doesn't tell us this, but it is right. We can assume they are right angles in these. So what we're going to do is we're going to drop our height down where it would be here. And we have a right triangle here that's got a 4 height and the 5 hypotenuse. We need to find what this other length is so we can subtract it from the 9 and find what our other base is. So we're just going to call this L. So using Pythagorean theorem, L squared plus 4 squared is equal to 5 squared. So that's going to be L squared plus 16 equal to 25. So we need to subtract 16 from both sides. And L squared is equal to 9. It's a nice perfect square. So that's just 3. So now we know what our L part is. Our base 1 up on top, or base 2 since you already have one of the bases, is going to be equal to 9 minus 3, or 6. So we have one base is 9, one base is 6. Now we're going to go ahead and find the area of our trapezoid. Now, what we could have done is just found the area of the triangle, but we still would need to know what L is. We wouldn't need to know what B1 is. And then we could just find the area of the rectangle part and be done, add them up together. But the easier thing to do is just to do one shape, right? So the area for 2 shapes and adding them. We will do composite figures later on, though. So area of a trapezoid, again, height times base 1 plus base 2 over 2. Our height here is 4 times 6 plus 9 divided by 2. Now, what I like to do here, since the 4 is outside of our parentheses and we're dividing by 2, we're just going to go ahead and divide by 2 now. So that's going to be 2 times 6 plus 9 is 15. So now we just had to multiply 2 times 15, and we have our area of a trapezoid is 30 square feet. And that is the area of a deck, so that logically makes sense. So the next one we're going to look at is the area of a rhombus or a kite. So the reason we're doing these together is they actually use the same formula. Now, rhombi are technically also parallelograms that you can use the parallelogram formula to use as well. It depends on what's given to you. But for the sake of these, we're going to be looking at the diagonals, and you just multiply the diagonals together, divide by 2, or multiply by 1/2, whatever you want to do. Same thing for a kite. So here we have a kite and a rhombus, and we're going to find the area for both of them. So the first one, A, is actually giving us the area, or not the area, the diagonals already. So all we have to do is plug it into the formula. So the area of this kite is going to be, again, I'm going to put the 2 on the bottom. So it's going to be 7 times 12 divided by 2. Again, hopefully you know what 7 times 12 is, 84, right? But you can also just divide 12 by 2, and that's going to be 6. So it's 7 times 6. Whichever one you want to do. So again, that'll be 84 over 2. So the area of the kite is 42 square feet. That's a huge kite. And then the last one for number 3 here, part B, is a rhombus. We're missing parts, but we do know that they are equal because it is a rhombus. So there's 9 and a 7 there. So that means one diagonal is 14, one diagonal is 18. So we'll write that off to the side here. D1 is 14, D2 is 18. So the area of our rhombus, again, is going to be the diagonals multiplied together. So 14 times 18 divided by 2. Now, this one's a little bit uglier on top, so I'm going to go ahead and actually divide it out. So 14 divided by 2 is going to be 7. So it's 7 times 18. No, you do not divide both numbers by the 2. Just one. You can divide either one, the 18 or the 14, but not both. So now, again, 7 times 18 isn't a nice, convenient number, but 7 times 10 is 70. 7 times 8 is 56. So 56 plus 70 gets you 126. And this one's inches, so it's square inches. So now again, here we have a rhombus. This one has some things going on. So one diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 64 square inches, we want to find the lengths of the diagonals. So we're working backwards here, but we do know some information about the 2 diagonals. So we know that 2 times diagonal 1 is equal to diagonal 2. We also know that the area of a rhombus is 64, and that's going to be equal to D1 times D2 over 2. So if I replace D2 with 2D1, it was 64 equal to D1 times 2D1 over 2. So multiplying D1 times 2D1 gets us 2D1 squared. And now we have a 2 over 2. Those are going to cancel. So 64 is equal to D1 squared. And 64 is a perfect square for 8. So D1 is 8. And we do have a unit. Inches. So it's 8 inches for D1. So now you figure out what D2 is. And we know that 2 times D1, which is 8, is equal to D2. 2 times 8 is 16, so this is 16 inches. Not too bad. So this is kind of just a general guide for areas of different polygons, so parallelograms, triangles, trapezoids, rhombis, and kites. These are all the ones we looked at so far. We're going to look at circles next, but they're not polygons, so that's why this is recapping it now. And that's it for this video.